and welcome to In the Lab with me and Mr. Wilson. Now, all this week we're going to be answering your space-related questions. So, loads of people have sent questions in, and we've put them into different topics depending on what we want to answer each day. The topic for today is the general topic of space. Yes, thank you, Mr. Wilson. So, here is the first question. It goes like this. Space, how big is it?
Big, I think is a good answer. Very, maybe another one. To go, actually, so from Earth, the furthest distance that we've ever seen is about 46 billion light years. So that means that light would to travel a distance, if it took 46 billion years and added that all together, how long light had travelled in a year, in that amount of time, that would be the very edge that we've seen. So if we sort of like think of the universe as a general sort of like sphere or as a ball, we imagine if it was 46 billion to one end, we'd imagine it to be the same the other way, giving us a rough estimate of about 93 billion light years for the observable universe, but the actual universe could be even bigger. So general answer is very big, probably unknown, but the observable universe is about 46 billion light years is the furthest point we've seen away, making it 93 billion total.
Fascinating. You could say elementary. There you go. Well, it's secondary actually, not elementary, because we're in a secondary school. Second question, why is it called space? Because this is space around us here, but why is that called space over there?
Yeah, I think it's mostly because it's just empty. It's just void of us. We understand the Earth is where rocks and the water and the oceans and stuff is. We have the atmosphere, which is filled with air, and then everything else is just empty space. It's just void of everything.
Do you know what? I forgot to say that the questions so far were from Ray and from Oscar, because we're going to tell you who asked the questions. The next question is, Emily asks this, can I go to space? And I would say, yes, Emily, the sooner the better. No, that's not true. That is not true. Can Emily go to space?
Emily can go to space. There are a number of possibilities at the moment for getting to space. Some of them are easier than others. Most of them, though, are pretty expensive or pretty long lasting. You can either train to become an astronaut. The European Space Agency, or ESA, they recruit astronauts every year. They last year recruited for their current scope of space flights sort of thing. So you can apply to them, and as long as you are trained in a specific area or you have fighter pilot training, you can become an astronaut through general training, or you can just pay, which is something that may come up in a later question.
Well, it is the next question. In fact, Jacob asks, when will commercial space travel be able or possible for normal people, maybe even abnormal people? It's up to you.
Yeah, well, at the moment it's just for pretty rich people. Right. So the current sort of space flight sort of stuff we've had, like Jeff Bezos on this, the Amazon sort of ventured, sort of not SpaceX, that's Elon Musk, but working along with Virgin Galactic, which is Richard Branson sort of stuff. They have been able to send some commercial people up into space. The Virgin Galactic flights, which are run by Richard Branson's Virgin, they cost about £100,000 per seat. They reckon it's going to come down to. At the moment, though, it's only a mere £450,000 for a seat, and that skims ever so slightly into the edge of space, and the space flight doesn't last very long. They don't even go to orbit.
£450,000.
Just to skim the edge.
So teachers could afford it then?
Yes.
Okay.
I'll expense that one.
Yeah. Next one. How do asteroids come shooting down from space? You might have to remind us, what is an asteroid first?
Yes, so common thing. We've got asteroids, we have meteorites, and we have comets, and people sort of use those three words interchangeably, but we are different things. So a comet is a sort of large rocky object that has a very elliptical or oval shaped orbit. It's a very eccentric orbit, we say, that orbits around a star. So we have Halley's Comet, for example, that orbits around our sun, that we see every 30 odd years. I can't remember exactly how long it is, maybe even longer, I can't remember.
Oh, I know, it's about 70, 78 years,
Yeah, 76, there we go, 76 years. I knew it was quite a long time that we see it every 76 years, Halley's Comet. And they will never crash into Earth unless we get incredibly unlucky, or we get some really far out ones that are on a collision course with Earth, but very unlikely for comets to impact with Earth. Asteroids, though, are lumps of smaller rock that will get caught by the Earth's gravity. And when they get caught by the Earth's gravity and they enter the atmosphere, they become a meteorite. And so gravity is what pulls them down into space. Asteroids pulled in by gravity down from space towards Earth, and as they come in, they get very, very hot, and then they sort of like can impact the Earth as a meteorite, which famously killed some dinosaurs.
Well, and that would be a shooting star, we'd say.
No, a shooting star would... Well, you could say a shooting star is a very, very small meteorite.
Right.
And they nearly always just burn up on the surface. Like, see that flash of light and then they burn out. They don't last the entire distance. If it was a full meteorite rather than a shooting star, it would end up impacting the Earth. So yes, a shooting star is a very small meteorite, yes.
Fantastic, thank you for that. Well, the last two questions were from Jacob and Jack, so thank you to those two. Harry has asked the next question. He is saying, if space is a vacuum, where does stuff go? Where does it go?
Very valid point. It just kind of stays in space. There's just a lot of space to sort of like hold all the stuff. So in general, a vacuum is something that's devoid of particles. Space is as close as we get to a good vacuum, but space still has about 3 or 4 atoms per meter cubed, which, for perspective, is insane. You have hundreds of millions of particles in a meter cubed of air, so to get down to only 3 or 4 tiny atoms is incredible.
That's
but
nothing.
Means that we get rapid diffusion. If you were to like open up a canister of oxygen in space, that oxygen would evacuate into space and it would diffuse and spread out the same way that if you spray a bottle of perfume in one side of a room, that smell will diffuse and you can smell it on the other side of the room in a little bit of time because of diffusion as it moves throughout the room. But space, it does the same, but it's just so big and so empty that everything just spreads out until eventually it's just sort of spread out back into space.
Well, fair enough then. Now, Max has a good question here. Emily might need to know this if she's going to space. How long can you survive in space without a helmet on?
Yes, so, not very. It's going to be quite a painful experience. I think, not that I would want to experience it. So the general consensus is that you can last about 15 seconds. So the first thing that will happen is if you've got any oxygen left inside your lungs, they will balloon up. The oxygen and the sort of like the gases in your blood will also inflate, meaning you'll probably balloon up to about twice your size. However, your skin's pretty elastic, that probably won't kill you. After about 15 seconds though, you'll start to asphyxiate because you'll be running out of oxygen, and generally you'd also start to freeze as well. So space is incredibly cold, so you'd start to freeze as well, unless you were fortunate to be close to a star, in which case you would burn to a crisp. So after about 15 seconds you would pass out due from lack of oxygen, and then you would just slowly turn into a massive gigantic ice block frozen in space. You would eventually decompose because of gut bacteria, but that would be incredibly slow because of you being frozen and then working at a very slow rate. So you'd probably last about 15 seconds, but you'd also inflate massively.
Okay, so Max, you might not want to try that for at all, actually. If space is an empty vacuum, this is a question from Ava, if it's an empty vacuum, how come space is so colourful? I mean, just like your picture there, it's amazingly colourful. Why? What's going on?
Yeah, absolutely. So, unfortunately, space is not actually this colourful. It's a quite sad fact. It's a thing that they use by NASA astronauts and other sort of like astronomers. All the sort of like wavelengths of light that get emitted from red to blue, red and blues actually being the most common, but we get them all emitted from these beautiful things like galaxies, which is what we can see behind this lovely spiral galaxy. However, we also get lots of UV rays and X-rays and gamma rays emitted by these things, this huge electromagnetic spectrum, which obviously our eyes can't see. However, things like the Hubble telescope and eventually the James Webb telescope, which is recently being deployed, we can capture that information, but obviously our human eyes can't see it, so they use computers to turn that information into a visible thing, and they tend to use very pretty colours to make things look more dramatic, so like the pockets of pink and blues representing different bursts of different types of UV or microwave bursts sort of thing. But unfortunately, space is not quite as pretty as NASA makes it out to be.
Well, fair enough, there you go. I hope you enjoyed this particular investigation into space. Before we finish, we've got a little feature that Mr. Wilson does not know about, and it is called Ask Mr. Wilson. And so, the question for today, I've got quite a few different ones, one for each day.
Okay.
I'm going to ask you this question.
Okay.
What colour is the sunset on Mars?
What colour is the sunset
Yes.
on Mars?
On Mars.
Okay, so sunsets on Earth are traditionally sort of like an orangey sort of colour, an orangey sort of hue.
That's true.
So
That is not the question then.
No, I'm just processing it at the moment.
I know.
Bit of problem-solving skills.
Procrastinating.
Exactly, yeah, making the mind spin on the background. So on Mars, obviously, we have a much less dense atmosphere. There's much less oxygen. It's much more carbon dioxide rich.
Interesting.
So you're going to get differences in the hue of the sunlight that you're going to see. So my prediction would be you're going to see it going slightly... I'm going to go yellow, but I reckon you could also make an argument for a light blue.
Oh, well, due to the dust
Yeah,
in the air,
red oxide, yeah.
it is
iron oxide.
blue.
Blue.
It is blue.
I got close.
He was there. Out of the two answers, he
Yeah.
was 50%.
So good,
correct.
look,
Yeah,
yeah.
we'll let you have that.
Yeah,
That was
yeah.
good. Right, tune in tomorrow because tomorrow we're going to do questions on black holes. So, see you there.